welcome back to AGT STEM. Today we're going to be watching a video on Moscovium. So without further ado, let's up to it.
Дорогие друзья, наконец выбрали название элемента 115 и новое название Moscovium. Dear friends, they've finally chosen the name for element 115, and the name is Moscovium, or perhaps with a Russian accent, Moscovium. The reason they have chosen a Russian name is because the element was synthesized for the first time in Dubna, somewhere to the north of Moscow. Dubna is the big research center where element synthesis has been studied for the last 30 or more years, originally under the leadership of Fluryov, after whom fluorovium was named quite recently. As with the other elements, the way that you make these elements is by accelerating very light iron at very high speed into a heavy element, and the nuclei fuse together. Now the problem is that both nuclei are positively charged, so you need a lot of energy to overcome the repulsion, positive against positive. But then once it's made, you don't want too much energy or it will immediately fall to bits. It's a bit like trying to jump from the ground onto the top of a flagpole. You might get there, but then overbalance straight away and fall off again. To do this, it's not just enough to choose the right atomic numbers, but you have to choose the right isotope. That's the atoms with the correct number of protons and neutrons, so that in combination you get a stable number. It's really important to understand that calcium-48 is a very rare isotope of calcium, less than 0.1% of naturally occurring calcium, and it's very expensive to produce, and there is only one plant in the whole of Russia, one plant in the whole world, that can make calcium-48. They ionize the calcium atoms and then separate them magnetically, as in a mass spectrometer. So you need huge amounts of electricity to produce a few milligrams of the compound. And apparently in one experiment in Dubna, they used $1 million worth of calcium-48. In these experiments, you're bombarding the target americium with trillions of calcium ions, and only very rarely does the correct fusion take place and you make one of the nuclei of element 115. Very fortunately, when you are successful, the element comes out of the back almost in a straight line, whereas when it blows up, fragments in something else, the fragments go in all directions. So if you put a very narrow slit behind your target, you can get not just element 115, but the subset of fragments that contains that, and most of the junk goes away. Moscovium is in group 15. That's the group that begins with nitrogen and then phosphorus. And what is interesting about this group is that it includes arsenic, which is very poisonous, used to be used by poisoners to kill their wives or husbands. But now, as you go down the group, you come to bismuth, the element immediately above Moscovium. Bismuth is surprisingly unpoisonous. It's even used in medicines. So it's a very interesting question. If you had a large quantity of Moscovium, would it be poisonous or would it not? It's also interesting to think whether the chemistry would be similar to that of phosphorus, arsenic and bismuth, or whether, like bismuth, it would be almost like a metal. You can get, for example, phosphorus pentafluoride, PF5, arsenic pentafluoride, but you don't get these pentafluorides of bismuth, or at least you don't get them so easily. So there'd be a lot of interesting chemistry, but unfortunately, the technology so far will not allow you to do that sort of chemistry. Moscow is one of my favorite cities, and so obviously I'm delighted. Moscovium is one of the few elements named after a capital city, and most of the others are not easily recognizable because, for example, lutetium is named after Paris, but it's a Latin name that, unless you know, doesn't seem to relate to Paris at all. So I think it's a very good name. As I mentioned before, Scottish viewers will like it because it has a symbol MC, and many Scottish surnames begin with MC. So there are going to be a lot of people in Scotland who can now spell their name with the elements of the periodic table. Making Moscovium has been a fantastic piece of international collaboration because although the experiments were done in Russia, they relied on having samples of americium which were made in America. These are very specialist experiments where you need a particular facility that can make the isotope that you want. We're talking about the starting material of milligrams or less. So even if the process was very efficient, you would only get milligrams of the element. And because of the low probability forming them, we're talking about really quite small numbers of atoms being formed. And in this paper, which is about the heavy elements, they're giving the numbers of the atoms of these different elements, 118, 117, and so on. So for 115, the highest number that any lab has seen, that's in Dubna, is 27 atoms of a particular isotope. Just to make that clear, in my teacup, there are probably 10 to the 26 or 10 to the 27 atoms. It is really almost incalculable that you can start costing up this element atom by atom. And each atom, probably, if you take in all the costs, will cost millions of dollars. Whereas with gold, for millions of dollars, you can get several kilos. But for here, you've got one atom, and it doesn't last very long. So it's the ultimate gift to give to somebody. You might just have enough time to say, I love you, before the atom decays.
It's the $1 million atom.
Yes.
We already have an element named after Dubna, Dubnium. Is it overkill, now having Moscovium? Are they hogging all the names?
I think it's fair enough. You have to bear in mind that there are some places that have at least 4 elements named after them, particularly Itaby, the small island near Stockholm, and the Californium, Berkelium, Lawrencium, and Livermorium are all in California. So I don't think it's unreasonable. In my pocket, I've got this.
Thank you so much for watching, and we'll see you next time. Stay smart. Bye.